Hi everyone, today we are gonna take a look at how to use generative audio AI for musical expression. The machine learning model we are gonna use is called RAVE, Real-Time Audio Variational AutoEncoder. You can always check their GitHub repository for details and instruction. And now I'm gonna give you a quick tour of the RAVE training process and the potential usage. First of all, we need a dataset to train the model. You can either collect your own dataset or use some open source dataset from internet. Here I'm using a dataset made with short sound clips of Chinese fringe instruments, but I would recommend full track of music as dataset so more musical elements like rhythm can be learned by the model instead of just sound textures. And before starting training, you might consider the sample rate, cutting out some silence parts, and balancing the volume of each audio file within your dataset. You can train the model locally or online with services like Google Colab. To train it on local machine, you need to build the environment first. Here I'm using Conda. After installing necessary libraries, including Torch, Torch Audio, and of course RAVE. You can use this code to check if your computer is good to go. Training a RAVE model usually involves three separate steps, namely dataset preparation, training, and export. Here we are doing dataset preparation. For the training, I'm gonna use Google Colab since the GPUs here are powerful, but you have to pay for that. The training time for a single model using Colab should be around 1 week, so you might want to consider the balance between your money and time. During the training, we can use TensorBoard to monitor the training. You can check the logs here to see if the training process is running normally. The most important ones are distance, validation, and losses. Besides that, it's more reliable to check these audio results of every stage. And when you think it's good enough, you need to stop the training and export the model. Otherwise, you train it for weeks, you will find it overfitting, which means the output audio is almost the same as your dataset. RAVE has many different configurations. It's always a good idea to check their documents. In this case, I'm training 3 models at the same time with different configurations because I don't have enough time to train them over again. Yep, so if the model you trained is not performing well, you need to start over again. So here we have our trained model as TS files, and the RAVE is running on the max or pure data with an external called NN. You can find the links to NN on RAVE page. Okay, let's get into the usage of RAVE. Through my previous experience, I use it in 3 different ways. Firstly, we can use it as a prior model, which will generate audio automatically without input. It sounds like randomly walking in the latent space. Secondly, we can use it as style transformer. Here is the original track. And passing it through wave, we got this. Lastly, we can use it like an instrument. The basic idea is that you messing around with the latent space, you got sound. In this case, we'll find it difficult to explain the latent space. You can't tell what impact each dimension or number there will bring to the sound generated. All we can do is messing around with the latent space. It's not easy but interesting. And we can map the latent space with your interfaces. No matter it's an UI interface, a MIDI keyboard, or drum pad. Here I have a motion sensor, so we can do things like this. Alright, that's everything for today. Thanks for watching.